There we go. So we're going to talk about data. We're almost going back to not so much a basic, but kind of the first element we need to be discussing. I'm going to ask for a timer to be put in, otherwise I'm going to get lost with time. Please, thank you. You know, I get confused very easily, so
Right.
there we go. We might not do that.
Thank you.
So let's make a start in terms of this, the title of a panel is Breaking the Data Bottleneck, Improving AI Infrastructure for Scale, Compliance and Cost. So there's going to be a bit of overlap to what we discussed before, but we're looking at it from a slightly different perspective. I think, so it was interesting because I went to a conference earlier this week and I could hear a lot of people saying we still have clients who they build those major kind of data lake when they put all the data in, and we did it for Urich as well early on when they put all the data in and they just expect AI to be magic. And AI isn't magic, I know. We're not a Silicon Valley, so we can say that. But I guess there's still been some changes, I would say, in the last 2-3 years with kind of generative AI, large language models, in a way that maybe you would look at how you do the most basic thing about data, the kind of storing and the accessing. So it would be quite interesting to start a discussion in terms of, have you seen any changes in a way that you've kind of collected data, kind of the most basic thing? Have you done things differently in the last couple of years, or has there not been much changes despite the ChatGPT, the generative AI, the large language model? So maybe starting with you, Marina, and then can go across the floor.
Sure.
Marina,
before I start, just to say that I'm here in my personal capacity. So whatever I will be saying is my personal view and doesn't relate to information specific to any organization. So to your question, yes, of course, Gen AI, LLMs have reshaped the entire data lifecycle, starting from data collection to data storage, data processing. As an example, in terms of data collection, we're seeing more focus on hot data. So we need, given all the real-time processing, given all the massive amounts of data that we need to fit into the LLMs, we also need more agile solutions, more dynamic solutions, such as cloud-based or event-driven, data collection. In terms of storage, we've seen innovation as well. As an example, intelligent data tiering. So AI algos are able to assess how often different databases, how often they're being accessed, and then place them in tiers, like tiers for hot data or cold data tiers. And this has implications in terms of cost, in terms of performance, in terms of scalability. In terms of data pre-processing, which is hugely important in terms of what you're feeding into the LLMs, yes, there has been innovation as well. For example, we're seeing more automated tools, AI-powered tools, that they do the data cleaning, data validation. They're looking at the structuring of the data, the labeling of the data. So they're feeding back to the models higher quality data for processing, for training. So absolutely, there has been innovation. I would expect it to be a continuous journey, a transformative journey. And as Gen AI evolves, we could see even more novel digital architectures.
Neeraj, from your perspective, what has changed, what hasn't changed from you?
Golly, what's changed and what hasn't? So, look, I come from a background of financial services and consulting and obviously law now. And what's fundamentally changed is when you're in highly regulated industries, such as banks and financial services, I won't do the same caveat you did, Mario, but when we really work in multiple financial services organizations, highly regulated data, there's been huge regulation whereby you need to make sure you have really good foundational data for regulatory reporting purposes. And post the financial crisis, which happened in 2008, it became much more rigorous under a regulation called BCBS 239. So banks got super serious about really making sure that the data was clean, aggregated, good foundation on the platforms, resilience. So that's happened about 10 years ago. What's happened in the last 2.5 years, it's fundamentally around every single person, even my mum and dad, have taken the phone and they're able to use ChatGPT and whatnot. It's fundamentally gone into the hands of the consumer and everybody. And what that has meant is both in terms of at a board level. So our board has got increasingly interested. The conversation is always on AI, but it has come back to how are we going to make sure that the data sets are really clear for us to be able to create value from that data. And there are a few things that have happened. One is investment on, and we'll talk about this, what I call data foundation, because I truly believe there is a symbiotic relationship between data foundation and AI. And data foundation, really two parts. One, good old-fashioned data management, and second, a data platform which is able to house all that data and create all that capability. The second part really is making sure in terms of the quality and getting through all of that data sets, you're really able to have context. And I think in some of the previous sessions, we've talked about context. So in the industry that you operate in, what's become much, much more carefully done is the curation of data and the context of data for AI to be trained in, or in Gen AI to be trained in. So there's been huge movements in terms of data because there's a level of understanding going from regulation more to innovation, that good, solid data, well-rounded data, well-managed data is not only necessary in terms of actually analytics and visualization for AI to operate. And I firmly believe in terms of the grounding of the data, the training of the models, really fundamentally operates with regard to proprietary data sets. And those proprietary data sets can only be created through curating and managing that data effectively. And then the outcomes you get from any type of LLMs that you're performing becomes much, 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 much greater.
Yeah, so I see a lot of different challenges right now. So on one end, we work with a lot of very, very large scale customers, hyperscalers, second-tier hyperscalers that have, they're basically a massive amount of data. So some of the systems and the customers we work with, we, speak in exabytes of data, something that banks usually don't talk because the amount of data sets are much, much smaller. So there's obviously challenges in terms of how do you build resilient infrastructure to support these kind of scales. You need to design systems that are actually built for something is broken all the time versus everything is usually working, and you handle basically the exceptional case of something is down. So there's a whole thing around infrastructure. That includes obviously, GPU failures. You need to do more frequent checkpointing. There's very significant requirements in terms of bandwidth beside capacity you need to support there. So this is one challenge we see in the data industry. The other part is what both of you just mentioned. How do you actually handle this massive amount of data and very effectively can clean and prepare it actually for training or later, for example, for RAG workloads. And so for that, we decided that, and we actually, interestingly, thought about this quite a couple of years ago. We just launched a new product called Infinia. And what this does is it puts a massive amount of focus, not just on the data portion of it, because I think data has been handled over the years very, very well. The piece that was always missing is actually the metadata handling, because what we will see going forward, and that becomes more and more intense as more people adopt AI in many different use cases, is you need to be able to very effectively basically label and find data based on whatever context is within the data. To give you a practical example, imagine you want to build an autonomous car. It drives around and every sensor is constantly collecting data. You take a picture of something, with one of the cameras installed in the car. Well, what do you think how much metadata you need to attach to this picture? It's like GPS coordinates, what's the speed, what is the temperature, humidity, what car do you drive, in which direction are you going? Are you going uphill, downhill, all of these things? It's all metadata context you need to have around this picture in order to leverage this picture later effectively to train an autonomous car computer. And that description that I just provided is applicable to pretty much everything else. It doesn't matter if you're talking about medication, drug discovery, pharmaceutical. And so we believe in the end that, you need a data platform that cannot just handle data, but makes it very, very effective for the end user to find, create and enhance data based on metadata. And that is where we think, there's going to be significant challenges happening where we provide solution for customers that want to innovate in that space.
May I just come back?
Please go ahead.
I think, agree. I think that the one thing I would disagree is around, I've worked in 20 years in the space of data in multiple organizations. And I do agree in terms of metadata and tagging is vitally important. But some of the legacy organizations that exist, we have millions and millions of customer records, and they have been acquired over time. The quality of that data has been really lacking. Simple stuff. So a customer record where if we look at multiple records of the same customer that exists, which means we have missing information. Sometimes it's N Raja, sometimes it's Naresh Raja, sometimes it's Naresh Raja, right? Because it's been acquired in certain ways. So we have at least 3 records of the same customer, extremely poor data quality, which then really results, if you multiply that with, I've worked for 2 banks which had 30 million records of customers. And you multiply that out in terms of the quality of that data, but also the duplication of the records of that data, you have a really huge problem. So in one part, yes, I think the tagging is important, but the other fundamental is getting real control of actually the data that you hold, the context that you hold that data in, where it exists, where it goes from source to target. It is fundamentally.
But I think we actually agree, I think, because what I'm saying is you need a capability to more easily find the different variations of the names. And that comes actually with the fact that you need to provide more context of the data. So maybe the name is spelled differently, but maybe if you're from the US, your social security number on all the records is the same. So if you would be able to find things through different means, you could say, okay, the naming is slightly different, but the social security number matches. So let's try to look exclusively in the data, in your data pieces and say, hey, maybe we find other things that match, like the street address or at least the state, or, there's like a cosigner on the document, something like that. And that is exactly the point I wanted to make. This is all becoming so rich that you need to have platforms that combine the power of storing data with combining unlimited amount of metadata, because for every single record you store, you no longer have the 3, 4, 5 tags associated to it. You might have thousands potentially of metadata points to every single document you have in order to better find it and then do these exact comparison of the data, trying to find matches and basically automatically create it, because you can't go through millions and billions of records and manually do that. I guess you agree. You can't.
I would carry on, but I think the only problem is when you're in highly regulated industries, it's tough, because I've sat in a room where it's difficult, even in terms of those types of viewpoint. 7 out of those 8 points we can match. But the question then comes, do you need to go back to the custom to verify? Because from a regulatory perspective, we might. So there are complications and I don't know whether you want to come back in.
Yeah, I will just, and then I will let Dexter continue. I believe all 3 of us are in agreement. It goes back to the first point I made around the importance of pre-processing of data and ensuring the data is clean in order to process it. Right. In order to feed back to the models the right data. So I think all of us are in agreement.
Yeah, I mean, my next question would have been, what's the best way to do it? And we kind of already started to answer, but maybe. So every conference I've been to the last 12 months, everybody's mentioned agents. So I kind of want to know, in terms of data bottleneck, is agent a game changer? Doesn't it change anything? Do you need to do something different in terms of your data? I actually went to a conference where a couple of people were basically saying, agents are different in terms of, you use the data because, one, it has more understanding on the context, and it has a bit more understanding of having, in the sense he called it, having more memory in terms of going there. So does that change in terms of your data collection, your data storage, your data access? Is agent kind of a new thing? And I guess kind of follow up on that, because agents are the things from now, but next year might be something else, and in 2 years it'll be something else. So, not so much flexible, but how easy is it in terms of when you're going to get new type of application coming, to make sure that the way you store your data, the way you use your data is kind of fit for purpose in terms of going forward?
And I think
another question.
it's a very important point. So this is one of the reasons also in our new product. We do not just provide standard interfaces that people can interact with the system. So we have interfaces like an object store interface. You can do puts and gets to the system. There's also a key value interface where you can put and store metadata in a very, very efficient way into the system. And there are several other interfaces. But on top of that, we as a data platform provider cannot provide interfaces for any possible application out there. It's impossible to do that. So therefore, we decided to take a slightly different route. And so we basically package a software development kit as part of the product. And so the customer can actually integrate their own application or their own agents that they build with our SDK to highly optimize access the data and the metadata that they are actually storing in the system. So that allows them essentially to very low latency, very fast, high performance interact with the system. That all plays then also into the whole energy efficiency. How can I get all that data in smallest floor space and so on and so on? And we can talk a little bit more about that. But I really honestly believe the future is really, you need to have a platform that can handle data and metadata, and it needs to have a variety of interfaces to work with it. And it also needs to be essentially available everywhere. It's no longer good enough to put this in an appliance. You get this only on your on-prem solution. It needs to run in the cloud. It needs to run in neoclouds, NCPs, however you want to name all these different incarnations. At the edge, same problem. Some customers produce massive amount of data in a highly distributed way. How do you effectively store data, evaluate them at the edge, filter out only the things that you actually really care about, bring them back into a data center or in a cloud instance to then actually further work with it? These are all the challenges we're gonna run into when this becomes more and more mainstream, and it's gonna get more and more adopted. And you need to have something to be ready for that.
I think go ahead.
Marina,
Sure. You talk about the edge and cloud, and I agree with what you said. Just to mention a couple of use cases that I'm experiencing across the industry. In terms of edge, this is very, very useful, especially in terms of data privacy. So once you classify your data into sensitive and non-sensitive data, you can store it locally at the edge, right? So that's beneficial, especially in terms of data privacy and the related regulations. Secondly, in terms of trading, edge helps you because you can do processing, especially for algo trading, high-frequency trading. Third, major issue in the industry historically, fraud, anti-money laundering. Again, having the data process closer to Genesis, real-time processing, you can get alerts much faster, and potentially that can be used as a preventative measure.
Yep.
In terms of when you mentioned about the cloud, I agree. The way right now I'm experiencing cloud across the board, it offers scalability, which is hugely important given the massive amount of data you need to feed back to the models. And also, major organizations, right? They can still have system failures. They can still be faced with disaster recovery. So cloud provides you with that BCP, the business continuity plan. So I agree.
Neeraj, yeah.
Yes, I think the kind of use cases with agentic AI that we're approaching is going to make a game changer. And the previous discussions we were having is there's obviously stock and flow, right? In terms of new records you're creating and new interactions you're having with customers, with products and so on. Where the agents and in a multi-agent environment is really helpful is to be able to orchestrate and ensure when you're onboarding a customer, onboarding a product, which type of data attributes already exist. And really the license to be able to clear up certain mischronalizations across it and work that through. That's going to be fundamental in terms of the actual process. If we look at the workflow of a customer onboarding or a new to product or a contact from a customer, being able to have the agents to work through what's the happy path for really ensuring the customer gets what they need to have. And then when there is an exception process, there are then being created more advanced agents to be able to actually deal with whichever those queries might be. And then there are then queries whereby your proportion is actually minimizing to say, okay, now you really need to seek to speak to a human being to be able to work that through. And that's what I see happening in terms of an agentic framework where there are multiple agents, but there's also the variations in the process being developed for human in the loop. And what's great is the manual percentage, which used to be existing, used to be quite high, right? People. And that is getting less and less and less in an agentic framework. And that's what's really happening in a number of e-commerce type industries.
I want to open it up for questions if there is anyone. There's one gentleman over there, and then there's Yurish at the back afterwards.
Yeah, I'm Jens Christensen, Key Research. I actually just recently had the manual labor or trying to identify identical customers, just a few thousand, a list of few thousand. It's a huge work, even with 2,000. So I like your example of 23 million and bank records, where you can imagine a billionaire in Santa Clara having the same name as a poor guy on the street. There could be pretty lucky things if you do wrong things. So I think that's a quite interesting case. But what I think is also interesting is that I 2 days ago participated in a AI seminar where they looked at medical examinations and found that if a clinician did the examination alone, he was here. If the AI agentic did here, it was there. If they did it together, it was lower. So the agentic or the machine did better than having help from the clinicians. So my question, I don't know, it's maybe most you, Neeraj, but maybe all of you, is could you imagine a situation where it's actually better to leave the agentics alone when merging records than having people involved?
I think it's a staged approach probably. So the way I would approach this problem is I would try to find an agent that looks at, just first the name. If there is no match on the name, but the names look very similar, which you can, find out with vectorization and similarity comparison, you would go into the next phase and say, okay, are there any additional matching things like a street? And if you find the same street and a similar name, you put them together. That doesn't necessarily mean it's the same person, because there could be by accident, whatever your uncle moves into the place that you lived before, and you have the same last name, and it thinks now all of a sudden it's the same person, but it's actually not. So you do this and you put them on a list of, say, hey, these are things I've merged, but the things that you can easily merge because you find lots of similarities very quickly is probably the majority of the work. And so that you get this 90% out of the way. And then the 10% that is left, you need another agent that doesn't look at, 2 or 3 things. It needs to look at maybe 5 or 6 things. And if you have 100% matches there, you can reduce, another 7% of that pile. And then there is 3% left, and you have now something that looks at even more records and try to cross-connect, maybe with other information you can find, publicly. And whatever is left, that's then the human in the loop, as Neeraj just said. You basically need somebody with an actual, quote unquote brain that looks at it and says, okay, yeah, these 2 things look the same, but they're actually definitely 2 different people, because one is, 20 years older than the other, and it didn't immediately spot this because the signature or the writing was so bad that the, agent couldn't automatically detect it. And therefore it's pretty clear it's 2 different people. But I think it's a combination of a hierarchy on how much more intensive processing you do, where there is more uncertainty, up to a point where you just can't automate it, and then you need somebody to actually look at it. And I think the same is, as I said, true for other industries. Autonomous driving is the same thing. There's only so much computational power you can put on something to detect if this is a stop sign. If there is a branch in front of the stop sign and you see only teeny tiny corners, well, it could potentially be, 3 different signs. And it doesn't matter how much computational power you put on it. You need to reference it with other things that could be, public maps or something like that in order to figure out, is it really a stop sign or not, if you don't want to personally go there. And I think it's kind of a very similar problem, and it just needs to be broken down in smaller pieces and do them one at a time.
I think if I take the 2 examples you made, so I'm involved with something for Data for Good, which is where we're trying to link in behavioral data with health data, working with universities and health companies, but also institutions, commercial institutions. The whole purpose of that, it's for social good, is to actually start to predict. Can we start to predict people's potential diseases they're going to have based on historical data sets? And therefore, you could create a course. What's interesting on the point you made around, is AI getting better than humans in that type of process? There is research that's been done whereby, in terms of the eyes, that the records in terms of whether someone's going to have eye cancer or they're going to go blind, AI has got a much better rate based on looking at historical photos of the eye. I think it's 97, 98% than human ophthalmologists and opticians and eye specialists. So it's definitely the case where the actual, especially the advances in generative AI, where there is huge amounts of those data sets in terms of very clear pictures, text, etc., that consumes, it's already happening. So I think that's definitely going to be the case going forward. I think the second bit on the point around the customer data, and we can talk afterwards in the break, is the point I was making is this is where I think it's going to be around. There used to be automation, which started to really look at fuzzy logic to start clearing up the different types of misnomers. I think what's going to be important for institutions, going back to the very first question, is how they orchestrate the onboarding, how they orchestrate the data collection is going to make a massive difference. And I work with a number of organizations, and one of the things that's scaring a lot of, we talked about banks in the very beginning, is that's all been set from a historical data set. And now they're going to, what the real topic in the industry at the moment for any part is, you're going to have agents that's acting on your behalf with every organization. So you need to make sure your data sets and your agents are set up appropriately to be able to deal with other agents from other organizations and individuals. And that's going to be the next big thing that's going to come through.
So if I got it right, one part of your question is whether AI can provide better diagnosis or prognosis, right, in terms of diseases. In terms of the medical profession, one of the biggest challenges has been data. And it's basically data sharing. So there have been limitations in getting data. So the AI is working on what it has, right, on what's available. So personally, because I have friends who are in this field, right, there's not a huge data lake, and this is off the record, there's not a huge data lake of personal details of people across the globe who have experienced similar diseases, right? So right now, how would we know with a high degree of certainty what the prognosis would be if there are data limitations? So is that data coming from a specific region? Is that data coming from a specific race, gender, etc.? So historically, in the medical field, there have been limitations. So you were constrained in terms of the data and the data records, or even data sharing between labs, between hospitals and countries. Yeah. So I would agree, human collaboration is very, very important. So we need to work closer between us as humans and also leverage the new tools and new technology. Yeah. And there is lots of evolution in the medical field as well. So you can use AI, you can use Gen AI not to identify better treatments, better combination of treatments, given the stage, of a disease. So there's lots of evolution, but again, there are limitations to take into account.
Thank you. You're addressing you on the microphone. Yeah.
Okay. Thank you. So all those data problems, issue that theoretically are not there, but we find them in the real life. Of course, we can invest in a good data platform, so we can invest time, money, and so on, and get, super duper data platform in 2, 3, 4 years maybe, but also delay maybe even the AI advancement before we have the data sorted out and ready and we are confident and so on. In this trade-off of how much we would like to delay our advancement on the AI in order to sort the data, what is in your opinion as a sweet spot? So how complex should be the data platform and how much should we invest before saying, okay, that's enough, let's go with agents and AI and all that stuff?
Look, I'll start, and I'm sure my colleagues all have views. And this is something I said at the very beginning, it's about data foundation. And Sven, please bear with me, it's not just about the data platform, right? And it's about the data foundation, which is, first part of the question is, you need to have the data management right. You can have the best platform, and there are multiple ones available in the market, but without actually orchestrating with data management around what is your critical data, how are you going to actually look at your metadata, how are you going to make sure your quality of data from rules to measures, all the way through to lineage, establishing the right protocols, your ETL, and to be able to consume, and the architecture to bring all of that data in, that the platform's not going to do anything. So that's one part. The second is obviously having the right data platform in place to be able to integrate that together. And that also opens up, and we've just done that recently in the organization I work for, is it's opened up a huge amount of AI use cases, where by having the data foundation, data management and platform in place has meant we've actually tried to train the data in terms of grounding and excellence documents. So the actual generation of our legal AI system that we built was based on good quality data sets that's been used. So that's fundamental. The second part of your question is around when do you need to wait till you invest? I've never believed in waiting for getting everything resolved, because if you really start to tackle all of the data quality and getting your perfect infrastructure and architecture in place, it costs millions. And boards and stakeholders are not really going to wait for that. So I've always really kind of advocated, take it on a use case by use case basis. So in the last three organizational ways, we actually prioritize 3 to 4 use cases, which has the most amount of value to be able to get to. And then kick off the program and initiative based on really which type of data attributes are going to serve as many of those use cases as possible, start to clean them up, and then obviously need a really sound data platform to be able to do that. And so if you do it in that way, you're able to get to value quicker within year one and be able to demonstrate value. And then over time, you're able to invest further in your platform, your capabilities, and also your data management.
And I think it's also important to start early just to see if the outcome actually is what you're looking for. Because, as we all already agreed on, shit in, shit out, this is just the way it works. But the best way to do is you start with what you have, and you actually have as the last step the human person with a thumbs up or thumbs down saying, this is actually correct data or this is wrong data, while you start cleaning up your data, making sure all the wrong information and noise and everything gets filtered out. Because over time, you hopefully see more people, giving thumbs up than thumbs down, and the information is more accurate. And over time, you can more rely on it. But it's really, it's a process you have to go through. And, I think you would both agree on, there's so many issues you need to tackle. And you need to tackle them all in parallel, because it's kind of an evolving thing until you actually have something that is really production ready. And there is so much innovation happening constantly. Should you immediately on day one buy the full system? Probably not. You start with something that makes sense to prototype and see end to end how everything works. And that's where you basically go in and start basically scaling everything up. But that is also a critical point, which is why you need to pick the right vendors from the beginning. They can't just do a POC and something, a sandbox. You need to have something that can actually operate at really large scale in production. And that's where these vendors become very valuable to work with.
Marina?
Just to add on that, there's lots of hype around Gen AI and trying to get all these models and expand on these models. Is this really what's happening in organizations? So organizations have a strategy, right? And you can have a data governance strategy, and you need to align it with your objectives. So in reality, what I would be looking for is really, as you said, use cases. Like as an organization, what should we be focusing on, and how these LLMs can help us achieve our strategic goal and also achieve ethical and responsible AI innovation. So personally, I would prioritize. I wouldn't necessarily focus on building an even more complicated model. I would prioritize. I would consider the cost of AI compute, align it with the objectives, and then put a roadmap on how to maximize that. Yeah. So to give you a very simple example, because I worked on this in the past, if I was building an LLM, let's say for anti-money laundering, I would start from the beginning. I would say, what's the current compute? What's the current model I can use and expand? And how can I take it to a level where it serves the purpose, right? And identifies the AM alerts and minimizes fraud risk. I wouldn't try to just get a very, very complicated model in place for the sake of it.
And I think the reality is also there's going to be more DeepSeek occurrences happening. This is actually what I think there is a huge difference between compute and data. So there will be no DeepSeek event for data, because the data you need to store is the data you need to store, assuming it's cleaned and it's, you remove the noise and everything. On the compute side, I believe we're going to see at least one or two more of those DeepSeek events where somebody smart that is under massive pressure to maximize the outcome with the resources they have, and they will provide another order of magnitude, improvement on that. And so that is why I think we're going to see a lot of innovation. And the good thing is every time something like that happens, it lowers the bar of entry for everybody else to participate in AI, because one of the biggest problems with AI still is not everybody can participate because A, they don't know exactly where to start, which is why you ask, should I delay or not? And then the price point of it. And given the amount of turnover and how fast things evolving, it's a critical, and complex decision when you're going to start.
And just to add on the cost and in terms of the models, there are, let's say, package models, right? But it doesn't mean that they're ready to use, especially if you have a big organization. You will need to tailor-made those packages, those models, to make it specific for your organizational needs, right? And what you're trying to get out of them. And again, there's cost involved.
And it's not good to hop every new model that
Exactly.
comes. Take one, optimize it to what you need. Now you went through this process one time, you know exactly what you need to do.
Yeah.
And then in a couple of months from now, maybe 3-4 models further, you're going to pick the new one. And the second time adopting it to your use is much simpler. And you ride that innovation move. Because you have to also think about, there is not going to be a lot of foundational model builders going, down the road. I mean, there's very few companies that can afford competing with double-digit $1 billion investment year by year in infrastructure. So the amount of foundational models will become less. And what will expand significantly are all these domain-specific, highly optimized, fine-tuned models. And that's where the real innovation for the individual industries actually will going to come from.
I think we had a question over there. Yes, please.
Yeah, so speaking of complex workflows and the multi-agent setups, I'm wondering, how do you practically make it work? Because let's say that 4 of us are 4 agents, and each depends on the work of the previous one. So let's say that he's 80% correct, and all of us are roughly 80% correct. If 2 of us, if I depend on his work, and we're both 80%, total accuracy is basically 64%, because the probability that I give you a correct answer if he makes a mistake is approximately 0. So 64% 2 of us, 64% 2 of them. If you multiply these 2 as well, that's roughly 40%.
Yeah.
40% accuracy does not seem very production ready. So how do you do that if the agents, if each individual agent, depending on the complexity of the job you provide to it, how are you going to do it if you're not at 99 point something?
Well, I think there's multiple options here. So you need to obviously not just build agents that try to find an answer. You also need to find agents that actually criticize the answer that was found, if it's actually plausible that this could be the correct answer. So you kind of turn the question around. And then the key thing, I think, is long-term is how do you combine the information from all of these different agents and different workflows in one single space. And that goes back to the point I made earlier on data versus metadata. I think one of the big challenges that we have today is that these things are really seen independently. People store data in, no matter if it's a block or a file or an object store. And then they have all these gazillions of different databases which have very special use cases that are sitting on the side and reference some data. And I think the future, you're going to have data that is co-located with metadata of different types. This could be anything from end-user provided metadata, agentic produced metadata. You can take a look at a picture with a very simplistic model that says, is this a human? Is this a pet? Is this a landscape? And you can add a label on it that says, hey, this is a pet. Now it can take a highly optimized model for pets and say, tell me what pet is that? The first one would not know. All it can do is this very high level categorization. The next one is going to know, hey, this is actually a cat. because it was trained for identifying different types of animals. It's going to be a cat, so you're going to put a cat label on it. So now you have a thing that is a cat-specific agentic agent, and he's going to look at it and he's going to find out, hey, this is a tuxedo cat. I know exactly it's a tuxedo cat because that's what I was trained for. And I think basically providing human-provided metadata, agentic-provided metadata, then you have the whole vectorization and indexing and all these other additional methods you can have in order to optimize the data. They all need to be in one place. And only if they're in one place, you can actually leverage the combined power of these different things to increase the accuracy of the outcome. At least that's my opinion.
Anybody else? Or
No, I don't have anything to add apart from my son's going through his GCSEs and maths GCSE, and your question just brought me back to thinking about probabilities.
The basics.
maybe because we've got a few minutes to go, I want to go back to one topic we wanted to discuss, but maybe not in as much depth as we originally decided, which is the importance of, and I'm losing my notes, but I remember what I want to say. So data governance.
Yes.
So very quickly, in a sense that how important do you think it is? And most, in terms of giving kind of a final words to the session, what advice would you give to the people in the room in terms of what to do, I guess, first? Or what's the main thing you need to do in that particular part?
Data governance. Well, it's hugely important, especially given the complexities and the rapid evolution of technology. So you need data governance. And first of all, the data governance, again, it needs to be aligned with your objectives, with your strategic goals as an organization. And it also needs to look at data end-to-end, the whole life cycle, from data collection, storage, all the way to deletion. Now, in terms of how I've experienced it across the board so far, it can be centralized. So you can have dedicated teams, like a chief data officer. You can have uniform policies across the organization. A very, very clear focus in data governance will be basically data security. You cannot have data governance. You cannot use data without having data security. And I will expand on that, without ensuring you have data privacy and you maintain the quality of data. So these would be the three key pillars of any data governance strategy. And these would be the pillars that align with regulatory expectations, make sure you adhere to those regulations. For example, on data quality, we're seeing lots of evolution in terms of innovation. So now we have automated auditing, in terms of data quality. In terms of data privacy, we referred to the edge before, right? Or there are other techniques like data anonymization that you can implement. In terms of data security, again, there are many, many tools you can apply, like specific role-based access controls. So there's lots and lots of focus. If I was to roll out the data strategy now, again, starting with the strategy goals, what we're trying to achieve, end-to-end, and focus on these three key pillars: quality, privacy, security, and make sure we adhere to the regulations.
We've got a minute left, so I think I'll be brief. I think this is my fourth chief data officer role, right? And one of the things that I've learned is, I agree with everything you say, is it depends on the organization. Governance can become quite a dirty word and quite a kind of non-sexy word. So right now, we call it data enablement, and fundamentally does all the things that we need to do. The way that you manage the way that data is acquired and created and fundamentally used is going to be important. But making it less onerous and making sure there's a balance between offense and defense really makes sure that you get to the right endpoint in terms of getting what you want. So my kind of key point is, don't get too held up on the actual theory and the focus of data governance. Is you've got to look at the organization, look at the risk appetite, and make sure you get to your end goals, which is, how are we going to get to really good quality data? Are we going to get in trouble with the regulators in any way? Are we managing the privacy and protection, as you said? But can we do it in a way which actually sticks and can be adopted within the organizations of thousands and thousands of people, and everybody knows what their responsibilities are with regard to data from creation, curation, all the way through to the end. That's the best way of making that actually work in practice.
Sven, final words to you.
Yeah, so for me, again, this is all primarily a matter of A, policies. How do you actually want to govern your data? And B, reflecting the information as metadata co-located to the data. If you store as metadata who accessed something, if you store as metadata what model was used to, or which model was used to train based on this data, you can always go back and basically connect the dots. And so for me, scalable metadata, which is not limited to a few entries, but potentially millions of metadata points per data, will enable governance at the same time, because you can store information, you can retrieve information, and you can have a total record of history, what happened with each individual data point in the system.
And very, very interesting final words to finish off on discussion. So I want to thank my three panelists for what has been, I think, a fascinating discussion in terms of data, because without data, we can't do none of these things that we're talking about, discussing. So thank you very much to the three of you.
Thank you.